Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Well, Luis Dussan, thank you so much for agreeing to do this. And I'm sorry I had to bump it from last week because we had horrendous storms here on the East Coast, as you may have heard. So I really appreciate your flexibility. But I've been excited about this because I know we met before when you were at AEye. We had a mutual, I think Intel Capital invested in AEye in our company. But you've had a very unique perspective and vision, a visionary in this space, in the autonomous vehicle space that we're both in, but especially with how you brought this very unique sensor and the sensor technology into the world of AVs and how they see and react to the environment around them. Perception is one of the biggest bottlenecks in AVs, or has been historically, I think, in my opinion. But it's interesting because you had a rich history too with like NASA deep space type technology, some technology as it relates to, was it intelligence, surveillance, and reconnaissance with aircraft, and I just kind of was curious, how did you sort of get involved with all that and sort of come to this world of, AVs, and what brought you into the world of autonomous vehicles? Like what led you to that point?
Wow. Oh, gee, I have to think back a little bit. But hey, thanks for having me, Paul. Appreciate it. I love what you're doing here, and excited when you invited me. Looking forward to a good conversation. So yeah, I mean, the background that you mentioned is obviously correct, and just thinking back about how I got into AVs, I think it was just a natural progression. It started with a love of learning physics, math, and then it sort of progressed into this startup, which was basically sort of an extension of something I became relatively good at in my days in the aerospace and defense industry, which was remote sensing, and surveillance, reconnaissance, things like that. And so LiDAR to me was a very natural sort of challenge at the time. And of course, the market that wanted it the most and was hungry for it the most at that time was automotive. So that's the natural progression into sort of automotive.
What year was that? Was that like roughly?
Well, the company was founded in 2013, but I started that journey probably earlier, 2010,
Right.
2007, when the DARPA Grand Challenge really kind of came into its own with Stanley and the Stanford team winning that the DARPA Grand Challenge. Really, inspired me to sort of create a better sensing concept than what they were using. I think they were using SICK LiDARs and
most of the teams,
right.
Most of the teams were using SICK LiDAR, and then there was Team Dad, who was the precursor to who had the Velodyne LiDAR.
Right.
Yeah.
And Dr. Adrian King, who's part of that team, is a great friend of mine. He's actually heavily involved in what I'm doing right now. And, but at that time, I actually didn't know him. In 2007, I did not know who he was. He did not know who I was. Shortly after, I was at Northrop Grumman and Lockheed Martin. It's kind of in between state. I got to meet him when I was at just doing some work that it was involved with aerospace and defense, and they did a lot of cutting edge stuff. So we got a chance to meet, and he ended up becoming sort of an advisor in sort of subsequent career paths that I took, and vice versa. He started a company, I started a company. We were both involved in those sort of things as advisors. But obviously, he was instrumental in AV in many ways. I mean, I don't know how much you know about him, but he really was, along with Gary Bradsky, created OpenCV. I mean, Gary Bradsky created OpenCV. Adrian and Gary wrote the book on OpenCV. That thing is 20 million downloads. Anybody who's done anything on perception has that code base. Um, and so he was really a pioneer in that area. And him and I were able to get along really well because we had a common interest. I was very much in perception, algorithms, sensing. He was very much into AI, robotics, self-driving. Obviously, he was a pioneer in that area.
Yeah.
And so I think that helped us to even solidify ourselves more into the AV side as opposed to just doing perception for it.
So that was 2013 when you started AI, it sounds like, right? And that was really the gold rush sort of year, I think. 2013, 12, 14, maybe that time when AVs were really kind of maybe at sort of seeing the beginning of their peak, I guess. The
Well,
Gartner hype
2013
cycle.
for sure is when I founded the company, but I would say
Yeah.
the real effort that I had, if you want to say when it really started, I would say 2007 was when I really started thinking about it, and then it took me
Wow.
to 2013 to really say, okay, it's time to start a company.
So what was the bottleneck that you like the specific sort of technical bottlenecks that you saw that sort of gave you the idea that hey, there's this missing piece needed, and yeah, what was that thought process like?
Software definability in the aerospace and defense industry is always really important because you need adaptability during the mission. So you don't want to have anything that's sort of fixed focus and does only one thing necessarily. I mean, sometimes you have to, but you want to be able to adapt, right? So it's all about having sensors and instrumentation that can change its behavior depending on what the mission is calling for. So software definability for me was a huge, very important thing. Obviously, size, weight, power, cost is also really important. And if you look in 2007 with the Velodyne sort of, bucket system, it was just untenable, right? That's not something you're going to create a commercial vehicle with. So I felt like the technology that I was working on, which included a lot of MEMS technology, was the right way to go. It was the answer that I think would reduce cost, increase resolution, range, reduce power. Um, it not just for LiDAR, because actually the first instantiation of that was a LiDAR that was automatic, that was mechanically bore sighted with a camera. So the LiDAR and the camera were no, you didn't need any software to bore sight them. And that, I think we were the first to produce a rich LiDAR colored point cloud, RGB point cloud at AEye. Um, that I was really proud of our team to really done that first. Now remember, when I say first, that means there was no post processing involved in order to combine those two. There was no parallax issues that you had to deal with. These two things were literally looking always at the same thing, and if you shake that or do anything, they're always aligned. And that, so that was kind of an important step, and sort of how things happen.
Yeah, yeah. Now, so were there some early customers that were like, because I think that was right around the time when Google was really doing their Street View stuff, or did they have their own at that point, or was this something that was becoming of interest to companies maybe who were doing mapping and what have you at that point? Because I think that was certainly an application, or were you just strictly focused on its use for autonomous control?
Our first customer was the Air Force. They wanted
Okay, cool.
to use it for a certain mission that they had in mind, and they sponsored a study on how to actually do that. So that was really the first money in. Um, then the second one was the Google X team, who crazy story, but it was actually, I think, Lewandowski's team at Google X, or before any of that stuff happened. And in fact, during the process of procuring it, he left and started Auto, I think it was.
Auto, yeah.
It was a crazy thing, but he actually helped us fundraise that order, that PO helped us fund, plus the Air Force one helped us actually fundraise. And we actually never delivered anything to him, which was a whole crazy story. But we ended up then hitching our wagon to GM. Kleiner Perkins. They did the Series A, and then eventually went public in 2021.
Wow, wow. And so now with the Air Force, so that does that imply that this had much greater range than what you would need for an autonomous vehicle, that application?
It could have greater range. The system's range is fun. So the way our system works, I think it's important to understand
Yeah, let's
that
talk about that.
you know th- the the way it actually works is it sends out one pixel at a time, right? So serially, it sends out pixels, and then and the transmitter is not the receiver. So the transmitter works as a uh, sort of a fire and forget kind of concept, and then the receiver can just sit there and wait however long it wants to for the return pulse to come back. In practice, that's not the case, but it can wait a long time. And so part of the reason why I think we were the first LiDAR to actually show kilometer range was because, most people were doing spinning systems or they were doing some other concept where the range, the time that the transmitter would be able to wait to see the return pulse was too short. You would never hit a kilometer. Um, and so that separation of the transmitter and the receiver, but still being bore sighted, was an important concept that allowed us to hit a kilometer range. And a kilometer range ended up being, and it could do more. It could do 5 kilometers if you really want to, but you'd be giving up resolution or update rate in order to accomplish that. And some of the Air Force's requirements were happy with that.
Yeah. What would that so um yeah, help me. So when you say bore sighted, can you define what that means in this context here for others as well?
Yeah, the the optical path for the transmitter and the receiver is coming from almost the exact same place. The camera on the system is actually bore sighted via beam splitter, so they are truly optically looking at the same thing, whereas is in a slightly parallax state, but it's close. It's like centimeters, and
Mhm.
that actually ended up being really important for us. Like for example, I'll give you a hint from behind the windshield, because we have that separation, we don't see that initial return, that bright return, in a blinding way. And so we don't have a problem with being behind the windshield. There's a lot of people that are literally transmit receiver the same, almost exact same path. That blinds them, and it could blind them for a while. And that's just like one of the patterns we have, one of the tricks we learned from years in testing in aerospace and defense environments. And it's one of several things that were built into the LiDAR.
And is that still based on, I mean, it must still be based on time of flight principles. It's just calculated from the transmitter is separate from the receiver. And
Yep.
so when you and it's just you're saying it's like a single is there like a spot distance for this that's like obviously at a kilometer, is that a big sort of spot distance for this beam or this
Well, yeah,
pixel?
yeah. It's a 2 milliradian beam, roughly speaking.
Okay.
So it's 2 milliradians, which corresponds to a certain spot size at a kilometer. So yeah,
Got it. Got it. Interesting. So now that's a single point. Now how do you get this sort of, and then you're just focusing these is it that you just focus all these different points at sort of an area of interest and then get what you want, or is it, how do you get the shape of a car, for example, out in the distance from?
well, you start at, so okay. So this is kind of an interesting sort of way of understanding it. So the system is fully feedback capable. In other words, every single frame, or even the top of the frame and the bottom of the frame, don't have to even be connected to each other as far as a pattern, temporally and spatially is concerned. So, simple way of thinking about it: you start out with a grid pattern, okay? And
Mhm.
this is the demonstration I did when I was raising I believe our seed round. Um, so I would have the camera look at the object, and then I would use an algorithm that would create feature points on that camera. So it starts out with a grid. Let's say I put my hand in front of it. This algorithm will then recompute what were the best points in order to interrogate that object on the fly. And then the very next frame will change the behavior of the interrogation pattern of the LiDAR so that it would interrogate the areas with the most information content at the highest density and the least information content with least density. And obviously it was to show the adaptability of this sensor.
Mhm.
Another way of thinking about it was you start out with a grid. Let's say the point cloud comes back with an object that looks very interesting, um, using various algorithms. And the next frame, let's say you have an 11 hertz system, a 10 hertz plus like a revisit frame. On that revisit frame, you could just say, hey, there's a target of interest. I want you to put a high resolution box around it and really interrogate that one for that one frame, and then go back to your regularly scheduled pattern. That was a way in which it was very adaptive, right? So you could just put an AI algorithm that could figure that out and do it on the fly, or a pre-programmed algorithm that doesn't even involve AI, maybe just some computer vision and some algorithms. And that was really powerful. And we demonstrated, I think we were the first ones and still maybe the only ones who could interrogate a field of view with the standard grid and then come back and interrogate something in detail really quick once something was found. Um, and that's the adaptability. That's the software definability capability that this system had.
Interesting, interesting. And so what and so it did this automatically, I guess, right? In terms of it would see something and then in the next sort of cycle sort of refocus what it's looking at. Did it so it did that automatically or with some sort of rules or you say AI programming to kind of know what to focus on? How did it know, in other words, if it's got like a scene of an environment to focus on like, pedestrians and cars versus trees or something? Or did it not did it do that or
Yeah, you attach the perception engine to it, and then the perception engine identifies an object as an object of interest, and then you just schedule it on the next one. It was something we did pretty routinely. You don't have to use artificial intelligence to do it.
Mhm.
You just used advanced algorithms. I think a lot of people confuse AI with advanced algorithms. These were just advanced algorithms could do it. There was an
Mhm.
effort to add artificial intelligence to the sensor. I think we actually tried to use one of Intel's neural computing platforms to do it. But yeah, the idea was that it would figure out what it was looking at and then come up with a better pattern to interrogate it later.
Hmm.
And that was, I think that actually is still very interesting to a lot of people, and there's some effort going on there to further investigate that.
Interesting. And so really the I mean range is of interest from an application standpoint, an AV application standpoint. I mean, only being able to see with some of these LiDAR effectively 50 meters or 100 meters maybe is not great when you're traveling at, higher speeds or you're looking down intersections where vehicles are traveling faster. So but this sensor had much greater range than that to be able to um, see at a distance given sort of this approach, I guess.
Well, it had
And
some innovative things. Number one, it could integrate several shots at the same object over time, assuming stability, and it would be able to trade frame rate, range, and resolution at any point in the field of view at any time. Any of those three would change with each other. So if you wanted, for example, longer range, you would have to give up update rate or resolution. One of those, right? And often those trades were very fine. Like people would be okay. Like if I'm going to go a kilometer out, then I'm going to increase my shot energy, and I'm going to lower the amount of the field of view that I
mhm,
want to see, but I want to concentrate on that particular object. That's a perfectly fine trade to make with our system. I will just add that for the automotive industry, I don't think they were ready for that at the time, and I think that the products that we ended up delivering to automotive were very much highway, one pattern, city, another pattern.
right.
But the system was capable of much, much more than that.
And is there a limit to the shot energy or
Yeah,
to the beam energy? Like
yeah,
practically, obviously,
yeah.
can't go through people, but I. That's probably a bad limit.
Yeah, built the
But
fiber laser. Fiber lasers, for anybody who knows, just, the longer you charge you get an increase in shot energy up to a certain limit, then you start having some effects that limit if eventually how strong it can be. And all the time it's doing eye safety calculations. With 1550, it's relatively forgiving to increase shot energy. So it was routine. It ended up being a routine algorithm that we would run.
interesting,
Yeah.
interesting. And so you mentioned MEMS, and I'm familiar with that. But can you define uh, like MEMS and like how it's different from what is I've seen some other technologies like FMCW
Yeah.
and why
Yeah.
why you
Sure.
incorporated one versus the other?
Yeah, so FMCW and MEMS are obviously two different parts of LiDAR. FMCW is your scanning concept. I mean, sorry, MEMS are your scanning concept. FMCW is a transmit receive concept. You oftentimes have to use a scanner with FMCW. There's just not a lot of companies. I don't think there's any of them. Maybe Aurora's Blackmore might be the only one that I think I butchered that name. Sorry, but they might be the only ones that don't use a polygon or didn't use a polygon or some kind of a spinning system or some kind of a galvo system. So most companies that are doing lidar today are either using galvos and spinning polygons. Um, I think we're the only ones using MEMS, maybe one other Chinese guy, competitor. And then there's the completely solid state approach. Those are really the main three approaches right now. And MEMS are just a scanner. So we created this random access MEMS two-mirror XY decoupled scan engine that was really powerful. I mean, so you give it a set of waypoints and then it follows it real quickly, and it's able to sort of if you think of like a random access scanner, it's what it was actually called, a random access scanner. So it could do any shape. In fact, when for Continental, after we signed with them, we gave them a little presentation where we actually we created a running horse, right? So we used this fluorescent paper, and we put the 1550 laser on it, and we created a movie of a running horse just to show the way that we could change the scan pattern on the fly. And we sent it to them as a kind of like welcome to the partnership. It was really cool.
Interesting, interesting. So the and MEMS stands for, do you know what that stands for offhand? I always forget
Well,
the
MEMS is micro electronic mechanical systems, but we use MOEMs, micro optical electronic mechanical
Okay,
systems, right?
got it.
Yeah. But like
Got
I just said, so the difference between that and FMCW is obviously that's the scanner. Polygon, galvos, MEMS, or no scanning, electronic scanning. That's the scanning concept. FMCW, which is obviously a way to make lasers a little bit like radar,
Mhm.
where you take advantage of the coherence concepts of light, um, to just include Doppler in the receive aspect of the signal. So you have time of flight, but it's not quite time of flight. Um, and you have this Doppler shift, which tells you the radial velocity of the object it hit. And it's
Right.
got certain limitations. It's usually a Fourier transform. So you actually get Doppler first and then you get the range, and the two can sort of collide sometimes, cause ambiguity. The electronics required are much more sophisticated. Um, and there's a lot of limitations of FMCW. Mostly the theoretical gain of FMCW is like 10 to the sixth, which is huge. It's like a massive amount. But in practical matter, the way you build it doesn't give you, it might give you 10 or 100x gain. And that's fundamentally the limitation you have. It just builds up a bunch of errors. And, you know, FMCW basically says, okay, as long as the transmit and the receive uh, wavefronts are really well aligned, I can get really interesting information.
Mhm.
But in the actual practice of building this, you don't get that kind of that kind of accuracy when the transmit and the receive wavelengths being wavefronts intersect. They don't intersect well, and therefore your game's not great. You have a bunch of other types of noises, and you have some artifacts associated with the decoding of the Fourier transform. So at the end of the day, it's a great concept that I think can find application in shorter ranges. But if what most people are doing today is using like a 10 millimeter aperture, which is huge, it isn't really automotive grade. I've done I think we spend a lot of time doing mechanical automotive grade analysis, vibration, shock, temperature, and then sort of the combined version test where you actually do all of them at the same time. And there's no polygon galvo system that's going to survive automotive grade. Um, the only systems that will survive will be MEMS based systems, and not all, and I'll then explain that in a second. Um, or solid state systems such as VXL SPAD concepts, right?
Yeah.
With respect to the MEMS, there was a few companies that tried to do MEMS, uh, but there are definite MOEMs, which is the micro mirrors, but you have to learn how to use them. So the approach we took was interesting. We took two small 1 millimeter MEMS, decoupled in X and Y, and we operated them in a way that made it very robust as far as when you're trying to do random access scanning. Other people would take arrays, like 3x3 MEMS arrays, and try to use them to increase in aperture and combine that with like a diode or a laser diode. Lots of problems with that. Diffraction efficiency is really bad. Um, the MEMS themselves aren't vibrating at the same speed, and so you spend a lot of time trying to fix that issue. It just became untenable. A lot of them didn't combine the combined X and Y. And anybody who's done MEMS and tries to combine X and Y axes, there's cross coupling, which is another huge issue. And so I think a lot of people that started out with MEMS sort of gave up on MEMS, went to polygons. And since we only had two small MEMS, the resonances on those were so high that we didn't even see automotive vibrations. It was like with solid state. And that's why we say it's like solid state, because it just didn't see those vibrations. And so it was really immune to that. And they were decoupled in X and Y. So that also gave us a lot of robustness against a lot of issues that most people were having. Most people haven't figured out how to use them. I think today we're probably the only MOEMS LiDAR company out there. And then there's a solid state. But before I go to that, any questions on that?
Yeah. Well, you mentioned, of course, automotive grade, and that's a key component to make something saleable and scalable, I guess, right, for this space. And there's so many lidar out there that at least that in the certainly in the older days that had reliability problems and what have you due to vibrations and the things that you alluded to. But then and we've we started to, of course, look at what how can we get to ASIL level compliance levels and things. And I know that I think you had a product that was either ASIL compliant or on its path to be. I can't remember offhand ASIL what the level was for this automotive safety standard. But how hard, like what's involved with getting that kind of compliance? How expensive or how complicated is that and lengthy? Is that like a clearly that's not something that happens overnight.
For us, how expensive, how hard is it? It's hard to do, right? I
Yeah.
mean, you're talking about going through a functional safety chain, doing analysis on all the failure mode. First, identifying the failure modes, identifying those what those are, describing them, figuring out if there are dependent failure modes from those, and then going through a mitigation for each one of those, and then implementing those mitigations. It's not easy. You have to understand your system in great detail, um, and you have to document it, and then you have to execute. You have to then put code, for example, that mitigates against it. And that code also itself has to be robust. So it isn't. It's a process. I mean, this is one of the reasons why it's so difficult to put anything on a vehicle, and why I think we should be grateful that we, for the last however many years, I don't know, in the automotive industry, has given us so many great things, because the amount of work that goes into putting something into a car that, think about, minus 40 to plus whatever, it depends on what you're doing, um, you know, survives vibration, shock, inexpensive. Um, I mean, there's so many things that the automotive industry and the automotive supply chain, the infrastructure, all the great people working in the OEMs, tier ones, tier twos, have given the world, because they're trying to solve this mass production problem in a very harsh environment. It's amazing. It's a lot of work, right? That's why it's 3 years. Why we have to have alpha sample, B sample, C sample before you traditionally you put vehicles on the road.
And I imagine that that's complicated for lidar based sensors in particular, because these are just more complicated. They seem like they're more complicated sensors than, of course, just standard radar, right? In terms of their construction and the technology behind them. There's certainly radars, been around longer, um, and of course, as you described, you're kind of evolving the product along the way, and then you have to get ASIL compliance for some sort of branch of it.
Mm-hmm.
That's a I mean, that sounds like a very challenging problem, and trying to keep the costs down too, to where the point where they would buy these things. I just
Yes.
remember working with some automotive folks, and we could buy certain sensor units for $5,000 a pop. They could get them for 500 or 250, but, like, you gotta get down to those numbers, it sounds like, right? Like a couple $100, and that that must be very challenging, obviously, with LiDAR plus ASIL and throwing in the ASIL level compliance.
Um, well, there's a lot to say about that. The I think, number one, the amount of volume that you need to reduce the cost, let's say from $15,000 a LiDAR unit to $300 is about 100,000 units a year, maybe 200,000 units a year. It's not a lot. It's not a ton of volume, right? The supply chains do a fun, and I want to shout out to the tier twos and tier ones all over the automotive industry, because this is one thing I learned. I could spend months redesigning something for lower cost. And what I learned in the automotive industry, which I think is important for anybody that's going into the automotive industry, is if you freeze the design and you work the supply chain and you let that system figure out how to lower the cost on a stable design, you're going to get so much lower in cost than you actually think you can. You think it's going to be this low, but it can actually go much lower. And that's what was amazing about the automotive industry. That one fact that I learned, I still am amazed by how well suppliers can lower costs once they know what the problem is, right? And I think as engineers, designers who haven't been through the full product lifecycle, you need to understand this. This is a really important thing. The closer you get to a stable design, the faster you get to a stable design, and then hand it off to manufacturing. Manufacturing can do an amazing job in lowering the cost. Does that answer the question? I mean, I think I think
Yeah,
it's
I
doable.
mean, basically, it's freezing the design and letting manufacturing and scale kick in. 100,000 units is Yeah, that maybe that's a make and model year of a car, right? A product, I guess if a manufacturer
Well, I
sells
mean,
50
it's
to
a few,
100,000.
it's a few,
I'm sorry?
it's a few models,
Yeah.
right? Yeah, it's a few because I mean, you're still talking about a 350, maybe $400, maybe depends on the by the way, the type of lidar you're asking for. All right, so let's say $300 to $800 a unit. How many vehicles are going to support a 300 to 800 unit part? Most of the luxury vehicles, I mean, all the luxury vehicles, then, mid luxury levels will do that. But I think the automotive industry in the United States really had a tough time swallowing that number. Because you got to understand, take $100 and multiply that by 1 million units. That's a huge number. That's a lot of money to guarantee for one part, not knowing if something is actually going to generate revenue, if people are going to buy it. And it's maybe not 1 million, maybe it's 100,000. That's still a huge number. And so the automotive industry in the United States and Europe was sort of stuck with LiDAR in like, okay, you're at $800 ish, like
Mhm.
realistically for the volumes that we're talking about right now, which are not great. Um, what I mean, the question is, can the person at the dealer take, because then you're going to have to add 3 times that price to the whatever you put out on the vehicle, roughly speaking, right? Like rule of thumb. So at 800, you're talking about $2,500 to add that lidar into the vehicle, minimum, I think, today. And the question is, well, what does it do for the consumer? Will they pay that? And I think a lot of companies, OEMs, just didn't know how to monetize something like that. It doesn't matter whether it's lidar or whether it's radar or 4D radar or anything, just a widget. Like you have to be able to sell the consumer on that upgrade. And I think a lot of them were just hesitant to do that. And that's, I think, why you saw autonomy first drive LiDAR. And then you saw ADAS, the promise of better ADAS, sort of then kind of take over a little bit. And
Mhm.
then I think the disillusion with the volumes and the price point kind of came in. And then that sort of gave people pause. And then you add in chip shortage, COVID, worker strike, electrification. And then that's where I think you saw people going, okay, we can wait a little bit. I think now, today, I think it's starting to come back. Why? 2 reasons. One, China, which is a whole other topic, is using LiDAR. I think they're like 300,000 units a year now on vehicles, right? And on top of that, there is some automatic braking laws that are sort of coming down the pipe.
Yeah.
And let me just, for people who are vision people or radar people, I love cameras, radar, ultrasonics, and LiDAR. Um, it's not that hard to figure out. You're gonna need LiDAR to do anything like automatic brake. You're not gonna be able to guarantee anything with radar and cameras. There's too many radar issues, multi-path issues, holes, noise, and cameras are visually based. What happens at night? It's a simple question, right? What happens low contrast environments? And you have a lot of people going, "Oh well, we have low light cameras now that can see in the dark." But you have to have contrast in order to determine one object from another. Sometimes contrast suffers.
Yeah.
And you have to have dynamic range, right? Sometimes that suffers. You can't be blinded by the sun. Sometimes that suffers. Sometimes you can get fooled. Cameras are visual; they can get fooled by a picture. So it is a whole of sensor kind of concept that you need to do that. But I can tell you that the only direct measurement on without multipath noise that is a clear indication of what's in front of you is LiDAR right now. It's the only one. Now, if that's all you wanted to do, great. Then go for LiDAR. But there's a lot of things. You have to detect red lights. You need cameras. You have to
Sure.
be able to pull over the side of the road when there's a snowstorm or rainstorm. And the millimeter nature of radar is the only one that can see through that kind of ridiculousness. Not to drive, but to just kind of safely pull over. So all of them are needed.
Yeah.
And what I see still on the web today is just a bunch of people buying for one over the other when it's a
Well,
really
the
silly argument.
the classic, of course, is Elon Musk and his, religious. And I don't know if I want to use the term, but his focus on camera based technology. He thinks that he's like, his perspective, of course, is something to the effect of humans can be see with things that are kind of like cameras, and so therefore, with a fixed baseline and you've got two cameras, you should be able to detect distances to things and see things. What I'm in your camp in terms of laser lights, precise. It's why not use it? It's more deterministic. But what is your take on sort of the Elon Musk's take on cameras are the only way to go?
It's wrong. There's no sugarcoating it. I don't think he believes it, to be honest with you. The people at Tesla are, I would venture to say, are that are in the know probably realize they need LiDAR, but they're not going to convince Elon. It's just wrong. It's silly. It's a dumb argument. I'm not even sure why we're still having this argument. Yeah, it just, okay, you want to put an AI neural net, super, general AI system behind two cameras. Great. You're going to get 30,000 deaths a year. Is that what you want to do in the United States, 2 million worldwide? Uh, it- You know, anything you can say that says that, cameras are going to be better than, or let's do it a different way. If you had echolocation capability or X-ray vision that will allow you to like tell distances and see much better as a human, you would be a better driver. I mean, any way you want to try to make that analogy where you're saying that a camera and a computer, two cameras and a computer are going to outperform camera plus LiDAR plus radar is silly. Um, if you're trying to make the argument that, well, the cost is really high and therefore it's not mass producible, I think that's silly too. I mean, I just told you the example of once you know the mission, the supply chain will figure out how to do it. And you're almost there. LiDAR is coming down in price tremendously. Every year, the LiDAR industry makes new inroads into. Like, I'll give you a simple example. When we first started looking at in-gas focal plane arrays, they were like $5,000 for like VGA quality focal plane arrays. By the time we finished, we were able to figure out how to get that supply chain down to, you know, double digits. All right. So it's just silly. It's a silly thing to say that LiDAR is not going to continue to go down in price. It will. And it really needs the industry to just adopt it, at a certain volume, and I promise you, it'll go down in price. And I think these rules for automatic braking, which are beautifully performed by the correct software behind a lidar,
Hmm.
um, in acceptable ways, I think that will show people that the price of lidar in mass production can be very low.
So AEB, definitely, coming, being required not only for smaller vehicles, but soon to be for larger vehicles as well. We're involved in the transit, a lot of transit applications. And in that space too, buy America compliance, right? Because there's just, concerns that they don't want these things made, in other countries, and there's certain rules that AFTA has for certain transit vehicles and what have you. What's your take on building it in the United States versus building these elsewhere, the cost differences and the potential future security and safety concerns that might arise?
What are you gonna do about it? I mean, all the technology is is sourceable outside of the United States. and the ITAR restricted countries. I mean, China has pretty much all the technology that it needs to build LiDAR. I don't, I think the worry is that you have anything manufactured in some less than popular country in the United States, and then there's some firmware that's put in there that sort of does some bad stuff, or the supply chain is too dependent on it, and some kind of a sanction could cut that off, and then you'd have issues. I think those are all minimal at this point. I don't know that LiDAR, if you're specifically talking about LiDAR, I don't think LiDAR is at a position where that is a worry as much anymore. Now, having worked in aerospace and defense, we're always lasers and certain wavelengths of light was always really important um, for what we're trying to do. But I just don't see how that is that's out of the I mean, that's done. It's not that is not really controllable much anymore. You might be able to control some of the sensing side, the in-gas sensor side, a little bit, but even that's sort of in mainstream now, so that's kind of difficult to do. As far as large language models, um, they're downloadable anywhere in the world. At this point, not I mean, any future stuff you might be able to control, but I'm not sure that's stoppable either in any way, shape, or form. I think you just have to create large language models with some safeguard, and I'm talking about foundational models, not just the LLMs, just one part of it. Foundational models that people put out that are downloadable anywhere around the world today. I think they have to be created with some basic safety things in mind. But that's going to be, it's like trying to regulate the World Wide Web. It's difficult to do at this point too. But I think there's some practical things you can do.
Yeah, well,
So
let's talk
yeah,
about that. Like AI. What's your current take on sort of the current state of? I mean, AI is a very broad term, as you know. I mean, it could go back to rules based or expert systems. A lot of people conflate it with just deep learning systems, or of course now generative AI. Um, what's your sort of take on the implications of this new flavor of generative AI, perhaps on in the field of perception and maybe even its integration with lidar and what have you? How do you see these being converged and used together, and your concerns with it, safety?
um, I think that if you ask me if I'm concerned about like a general AI intelligence taking over the planet, and I'm not worried about that right now. I don't see that as an issue. I think if you ask me, are you worried that somebody is going to use the knowledge power of AI to do things they normally wouldn't be able to do because they wouldn't know how to do that? Yeah, that is something that I think is potentially problematic. Um, I think that there's
If that's a bad thing, whatever it is that they didn't know how to
you know
do, obviously, right?
so
But if
like
there's
don't make it easy to build a bomb. Don't make it easy to like show people how to make you know plastic guns, stuff like that. Like normally you would have to look it on the web and sort of like figure out how to do that and do a bunch of research. And the unfortunately beautiful thing about LLMs is they'll do all that work for you, right? You just say, hey, how do you do this? And then it shows you in layman readable terms how to do stuff like that. And I think that is something we want to think about doing. But I'm not worried about like Skynet taking over the world. Now there's paths for how something like that um, could potentially happen. But they're just not there yet. They're just, I mean, what an LLM essentially does is predict the next word. Really, that's all it's doing. It's predicting the next word based on a lot of previous words, right? But and then you have to add memory to it, and you have to add some schematics, schema on top of that to control. If you say, "Hi, my name is Louis," and then you ask it, "What's my name?" without the other things associated with an LM, it won't remember your name. It has to then remember that, and that is a whole separate process. And then there's branching points on what you ask and how it would respond to that. So so once I think people understand how large language models, which comprises generally the natural language processing version of Gen AI, I think people will be less worried about something like that. How to apply that tokenization concept, transformer concept to other things like pictures, moving pictures or images, sound. Um, that I think is a body of work that's you're seeing right now with Google and OpenAI
Mhm.
using the camera and its thing to kind of say, like turn over the hourglass and say, what's going to happen if I turn this over? It's like, well, it's going to start counting down. Like that is interesting. That's pretty powerful stuff. And I think the idea of then turning text to task is where a lot of people get this like Skynet concept, right? Where it sort of is able to manifest this. It's not just words; it's words attached to action. Um, and I think I mean there's some I don't want to say worry there, but like there's a lot of things that have to still happen. I think planning wise, not planning wise, but like the AI agents aren't great planners in themselves. They can repeat words that make it look like they're planning, right? Like,
Mhm.
if you ask 100 people, what would you do on a rainy day? And you ask an LM, what would you do on a rainy day? It could plan like that. Well, you should do this, right? And that's not really the planning we're talking about. We're talking about looking at complicated situations and then figuring out how to, you know, deal with it in a sort of a one-time basis kind of thing. That's not great. They're not great at that yet. And I think you need to be great at that in order to fully, and I think in order to do the kind of things we're thinking about, right? So I'm not worried about that. I'm not worried about that. I think that that's very far away, but I do think people should start looking at ways to mitigate that. I want to say one more thing. Large language models, the way transformers are used, the way that natural language processing was developed is very different for language, as far as I can tell, than it is for any other token. Like the words as tokens is different from like sound as a token, is different from images as a token, or 2 by 2 pixel sets. Those things are not the same. The language is a different beast altogether. While Gen AI seems to work well with language, it's not clear that those things apply well to other things. I think people are trying, like, for
Mhm.
example, understanding the road in front of the vehicle and then being able to extrapolate like what the vehicle is going to do now. That's work that's ongoing right now. But it's not clear that there's how that's going to work. And there are people much smarter than me that could explain that in much more detail.
Yeah. Well, I mean, it's interesting that you say all this because I think it's being able to analyze like a picture or an image is of course different from telling it to generate code to do that for you, right? Because and that's where I find it kind of interesting because I think it's pretty good at generating code. Like you could say generate, a lane keeping algorithm or something, and you might have to step it through and feed it some information along the way. But what it's doing is it's not actually analyzing the image. It's generating the code that would do ultimately the analysis of the image, and that's more inspectable, right? Like you can from a safety from a verify I guess a verification and validation perspective, you can verify and validate the code that it generates better than you can some neural network which is made of a bunch of weights, right? That is doing that sort of interpretation without giving you this intermediate feedback of the code that's actually doing it, right? And so, I think, yeah, this human co-pilot role with the generative AIs to sort of be the planner for it, right? And give it, tell it, I want you to do this and generate this code to do this thing and to generate this piece of code to do that thing. That there's definitely some emergent utility in that, in our world, right? Um, because you have a little bit more, you still wield sort of that human level input of being able to see what it's producing and trying to understand it. If it's producing source code that you can now understand, which is doing the image analysis or the perception.
I agree. I agree with you. But it has to be trained to do that. It's not just sort of learning it on its own. But yeah, I mean, writing code. So I guess you're making the leap there that if it can write its own code and then execute it, it's got a systematic feedback loop for how to learn. Is that the assertion
Well,
or?
no, I'm just saying, like, in terms of how to use the tool, how to use these tools to achieve, like this example of perception, like perceiving something in the environment and making sense out of it, and then doing something based on that. Like you can, like, there, people have been using deep, learning neural networks in autonomous vehicles for quite some time, right? Actually, and but they never, if there's an error or an issue, you can't really tell you why it caused that mistake per se, because it's just these neural networks are just these gigantic networks of numbers, right? And you can't look at these numbers and have any sense for, oh, that weight should have been, you know, zero point 0.7 instead of zero point 0.8, and that's why it ran over the dog, right? But it's but if you use this generative AI to generate the code that is making those decisions, that's something that you can inspect and give and iterate with and give constant feedback and sort of, you know,
Hmm. Yeah, but
know, uh,
I
uh,
mean,
that's the co-pilot role that I think is potentially useful for its application to our space. But I was
no, I
curious,
mean,
have
it's
you been
true.
thinking of its application?
Well, I mean, so I mean, the statement you made is accurate. It's hard to tell, but at the end of the day, like, let's say in pattern recognition, which was what they were initially developed for. I mean, these are very good pattern recognition algorithms, convolutional neural networks. It's going to tell you that it looked like the thing that I thought it was, but it wasn't above a certain threshold. And yeah, you're not going to figure out why it wasn't above a certain threshold because of that. That weight should have been higher or lower. But yeah, then the other thing, which it accurately detected as the thing that you were looking like a car or a pedestrian, would have been lower. So I think the answer is it's like, why do you find a certain vehicle attractive? Go in your brain and ask yourself. You were fully conscious, and you're going to be, well, I mean, I I I like this and I don't like that, but at the end of the day, you're not. I mean, I don't think it's doing anything that we. I think we're just surprised a lot by the fact that we can't tell why. Right? It's not an algorithm that has like a binary yes or no because it's really based on so many algorithms that become a probabilistic effect,
Mhm.
and it's over time that you're going to be able to train the system like you would do it too, right? If you how many times have you seen a fire hydrant at night with the shadows and thought, okay, that looks like a small person? You know, you can be fooled.
Sure.
I mean, if you're trying to mimic the brain, guess what? It's going to mimic the brain. So some of those are not surprising to me. But because it's different, like you can, it's not just a pattern. And in fact, anything can be defined as a pattern. And so by like a serial detection of a car, then figuring out what the drivable path is, and then trying to figure out how to go around the car. All of that can be done by a single sort of deep learning algorithm. If you do an end-to-end algorithm, and so you can claim, okay, is that really a pattern? And therefore, you're right. The question that you asked is can also be asked again. And in that case, it makes more sense as to why it failed. Um, but I don't know that I guess your question was, my point was, okay, sure, we don't know why exactly it fails, but I don't know exactly why people are surprised by that in some cases. Um, and so my argument is, just train it better,
Yeah. Well,
just to train it better.
it's not that, you're surprised that it fails, I guess. I mean, yeah, I mean that people will get surprised by that, but I guess it's in the automotive space, in the autonomous vehicle space, or even if it's being applied for ADAS purposes, trying to take this technology and apply it, and then trying to get those certification, get that verification and validation that it's going to work. I guess at some point, you have to do that, right? For it to
Oh
be
yeah,
able
no,
to.
no. Okay, I understand what you're saying now. You're talking about like, okay, how do you go from A sample, B sample to C sample on a vehicle that requires a certain level of binary yes and no functional safety for it to work, whereas you go into more of a probabilistic effect? Yeah, that is a great question, and the answer is nobody has quite figured it out yet.
Right.
And this is something that's hampering the OEMs as they continue to try to put what would be artificial intelligence behind some kind of a driving function like highway autopilot. And you're right, that is still an ongoing issue. And the answer. The answer is you train it, you train it, you train it, you put a certain number of hours behind it, and then you say, okay, we've tested the heck out of it. It's done a really good job. I'm gonna release it. And then one day it makes a mistake. Okay. But in that time that it made a mistake, was it better than a human? If so, then you're holding against a standard that is almost unfair, right? Like if you can go back and show, look, we instead of 33,000 accidents a year, we reduced it to 20,000. But you're like, but it's still called 20,000 accident. That is something that as a civilization, as a country, we have to think about, like, is that better? In any objective metric, that's better. But
But how do
it's
you get
like,
to that? How do you get to that? I mean,
you
obviously, you would have to deploy that many vehicles to that have this technology in it to get that statistic. And it's a chicken and egg problem. What if you can't, you're not going to deploy that many vehicles to get that statistic of, equivalence. Obviously, there's going to be a smaller subset. And then did you apply that? Was that did you just run it in the streets of San Francisco as robo taxis? And does that extrapolate to, the I-95 on the East Coast or the 101 on the West Coast? I mean, this, yeah, I mean, how do you get to that? How do you come up with a statistical model that says we've done all this testing and we're going to save more human lives with this than I mean, that's a tough one.
well, I mean, there are ways to do it, right? Simulation, testing, proving grounds, hours and hours of testing. And you monitor what you're testing, make sure it's not repetitive. Um, and then you get to a certain point. But I think there's other things too. Like you take Tesla, and I don't mean to pick on Tesla, but they're the easiest one to pick on, which is that Tesla itself has published data that indicates that their cars have prevented accidents. So you're like, okay, it's better, right? The problem that I have with Tesla and Elon, especially, is that his followers seem to think that it can do it's bulletproof, like it can do anything. And then you get these weird accidents that happen because people think that it can do things it can't. And I just wish he would be a little bit more responsible with his own people that are the fan bases driving the Teslas need to understand that that car has holes. And if you use it the wrong way, you're going to create an accident where normally you wouldn't have had an accident. Like when you give it way too much faith that it's going to perform a certain task. Don't do that.
Um,
Like it's not designed for that. Read the fine print on Tesla. Like they tell you that it can't do that. Um, and so I think that's where you get some of the issues associated
Isn't that
with.
human nature though? I mean, you're kind of driving there down a country road and you're letting it auto drive and you look down for a little bit and then, maybe you hit a deer because the one ran out in front of you and then the other one ran into the side of your car that was going to be unavoidable. And the technology just didn't pick it up, but maybe you could have, right? But you looked down I mean, it's just human nature, right? To kind of once something's
I'm
doing
not worried about
something.
that.
Yeah.
I think that would I don't have a Tesla fleet, but if I would venture to say that the numbers would play out better even if you did that. I think the things I have problems with people is they put like hand warmers on the steering wheel to like prevent the system from, warning you
Oh,
when it's stuff like that, or they fall asleep, on a traffic jam. We've seen the videos. I mean, the Tesla drivers put the videos out. You can just go see what they do.
yeah.
Um, so I think that's irresponsible. And
Oh, yeah, 100%. Well, that'd be like putting a brick on the pedal, right? You can't do it.
yeah, exactly. I mean, I think it's just, you gotta play within the rules. Now, you brought up something else that's interesting though, which is what something we are looking at right now, which is that just like pilots when they put it on uh what is it? Autopilot in the air, um, you know, there was this thing they went through, and a lot of people maybe know, I don't know, that they become complacent, right? They don't. So in two ways. One, they start losing attention to what's going on. Number one. Number two, they like the Asiana sort of incident, right, where they sort of didn't know what the alarm was, or were not trained to to uh, to understand how the airplane was acting when a certain alarm went off, and they did the wrong thing. So not being trained enough, or just forgetting your basic stuff
Mhm.
when you're there being complacent. Um, that the other thing was like you if you start hearing too many whistles and bells and things, you just start tuning them all out, right? So all of those things that were learned from the automatic pilot in airplanes can and will be learned uh, for people that are driving,
Mhm.
right? Like there was a study done which I thought was really interesting, which they tested. I think it was like I think Wendy Chu was the person who did it from Stanford. I could be wrong on that. So they tested the re-engagement of people on highway autopilot when they told them, okay, just don't do anything, but kind of like wait till something happens, and then something happens, and then their reaction time, because their like brain is asleep or disengaged, was a certain amount. And then they said, okay, they tested people that apparently like were on doing something, engaged with the video, their iPad, something, and then something happened, and then since their brain was stimulated, they were able to think faster and correct the action faster. So so they weren't looking at the road, but they were engaged. Their brain was engaged, right? So what that says is there's another danger, which is that you need to be engaged in something. Right now, think about what the mode of operation is. If you're driving Blue Cruise, Super Cruise, any highway autopilot system, you're supposed to be on the road looking, kind of being like, but what do you want to do? You want to do something else, right? And what this is saying is, okay, you're doing that, but you're like this, and then you're like, and then you kind of just lose track and you start falling asleep or you lose attention. Something happens, you're not ready. What this study is saying, hey, maybe you should be doing a little bit of this and a little bit of that. Keep your brain engaged because you're much faster. It's a really interesting
Huh,
study.
that
Um,
is interesting.
so some of that I think is going to start playing over the years as we start figuring out how to work with this human machine interface.
Maybe a little video game where you're shooting virtual,
Well,
cars out in front of your window.
I'm a big fan of AR HUDs. I think augmented reality heads-up displays are going to change the automotive industry in the future. I think that we're going to start seeing the human machine interface with with a car change drastically. That's something my team and I are doing right now is really paying a lot of attention to the human machine interface with the driver and the vehicle. We think it's sort of gone through so many different small changes that it's now incoherent. Think about what you're doing in the car. It's crazy. You have an ADAS system that's preventing you from making mistakes, but it's asking you to just sit there and kind of get into a state of hypnosis, and you're penalized for using screens and the phone, which, by the way, rightly so, because that's actually causing more accidents. Now, if you talk to the insurance companies, that's like the number one cause of accidents. Oh, I was looking at the map on the center console, or I was looking at the phone on my phone, and I wasn't paying attention. Remember, the study that I did was the car recognized it and said, "Hey, you have to take over," and you do it. I'm not talking about situations where the car has no idea what's going on, right? So in that situation, we are causing the accidents by moving more things that are taking our attention away from the driving experience. There's like, it's like a mess. It's like, that's not, if you had to redesign the car from scratch today, you would want to figure out how to create an interface that sort of included some of the functionality in your phone and your web things that was much more natural, much more coherent. And that starts with newer technologies. And those newer technologies that are out there are available. They should be integrated into vehicles, but they're not being.
Why does it take so long? I mean, like, even I mean, I have Apple CarPlay and all that, and even that, I mean, it just took so long. It still doesn't even work well, and I have like a new car, a fairly new car.
Because the relationship is broken from the beginning, I think.
Yeah.
I mean, think about it. Your smartphone came out in what, 2007? When did Apple CarPlay and Android Auto come in? 2018, 19, maybe? When people really started seeing it in vehicles? So that's what, over 10 years? Why?
Um,
Because fundamentally, there is a conflict of interest between Apple, Google, and OEMs. Fundamentally, there's a conflict of interest. The OEMs want the control back of their customers, and Apple and Google have it. And the OEMs don't have the wherewithal, the skill set, the business plan at all to figure out how to successfully pry that away from Apple and Google. And Apple and Google, by the way, also don't view the automotive and business as a particularly great business either. 100 million units a year. Okay, well, what that's compared to like every Apple and Android device in the world. It's not a whole lot. And then you're talking about way lower margins, way higher liability. So they're like, hey, we're happy to play with it, but here's the relationship between Android Auto and Apple CarPlay and the OEMs. We're not going to charge you royalty, but we will make you go through certifications. We will also require that you pay for any hardware that's needed to run our system. And then we will take all your data and you get nothing from us. Just be happy that you have our system in there and that you can sell vehicles because people won't buy your car unless you're in there. That's the relationship. Is that a good relationship? Do you think that's mutually beneficial?
it sounds a little combative.
No way, right?
Yeah. No, I know, and yeah, you see it firsthand in other ways, but yeah, it's a shame. I mean, it's I've got a 2023 vehicle, so it's not that old, and the CarPlay in it is buggy, buggy as hell.
Yeah, I mean, we finally went to Wi-Fi because we couldn't keep a USB cable working for more than about a month. That was crazy. And then the Wi-Fi, like I go through a certain part of town. I live in the valley, and every time I go through that part of town, I don't know why it shuts off the Wi-Fi, resets the system, and then put back. And I have yet to figure out why it still continues to do that.
Hmm. No.
But it's you're right. That is really a buggy aspect. And I don't get it.
Well, you touched on, kind of this new thing that you're doing, and I don't know what you can say about the stealth startup that you're working on, but what can you say about it, and like what prompted you to? I'm interested in sort of how you went from what you have been doing, at AI to this new venture, this transition.
I mean, I think the where it went was I knew nothing about the automotive industry when I started. I founded AI in 2013. By the time I took it public in 2021, I think I was much the same way as many, many first time founders messing around, dealing with the automotive industry feel, which is that it is, it isn't as exciting and organized as we might have initially have thought. Don't get me wrong. Like I said before, you have lots of great people working in the tier two, tier one, and OEM automotive industry, and they've given us great, amazing products over the years that have translated to advancements in our lifestyle, the betterment of our lifestyle. They do a lot of great things, right?
Hmm.
But they're at a point now where they're in a really difficult situation, which is to say they cannot, for whatever reason, they cannot figure out how to change their business model and their they can't hire the people they need to make the next transition. And I think it's going through a very important transition. First, I think there was the car, then there's the electric car, and now I think you're moving into an AI car. But unfortunately for the OEMs, I think it was the same transition when you went from a regular landline phone to a cell phone, feature phone, to the smartphone. I Nokia and Motorola were the ones that were leading, if my memory is correct, when cell phones came out.
Hmm.
Where are they now? Nowhere. That's the OEMs for today. They could not see or figure out how to make the transition to the smartphone. Other people are going to make that transition before they are. And I think some of them realize that, but not all. And I think it's a real problem. I think that one of the things I'm doing is I'm trying to help them make that transition. Uh, I think China has made that transition in a major way, and I think that's a huge threat to US and European OEMs. And I know a certain OEM told me that their sales in China dropped by 35%, I think last quarter. Not because they didn't have a good car, it's the same car, it was really good. It's just that they can't compete against the technology packages that the Chinese OEMs are offering. And so this thing from going from a regular cell phone to a smartphone is a transition that the OEMs, I don't see how. I mean, I've given up sort of on them on this. They don't have the wherewithal to do it. And and I think that there's going to be some potential changes over the next 5 years because of it.
And is that, I mean, so you think maybe the likes of like, just companies like the Teslas and the Rivians and what have you are the ones who are going to end up as newer comers adopting this faster and surpassing them? Is that?
I think newer entrants, yeah, but Tesla is about to become Nokia and Motorola if it doesn't do things like figure out that it needs LiDAR. I mean, some of that stuff is silly. Like, you know, stop fighting that fight. That's a dumb fight to, that's a dumb, you know, position to defend.
What do you think about like in the autonomous space? I know this is kind of like a pivot back, but um, there's a lot of these autonomous, what you might call bespoke or purpose built custom shuttles. You've seen like, I don't know if you remember Local Motors with their Ollie vehicle, and then there was the Navia shuttle, Easy Mile, and now there's Zoox has their pretty interesting. Yeah, well, Amazon, I guess, acquired them, Zoox, um, and like it manufacturing is very hard, right? And so the OEMs, they've got the manufacturing part down. Like Elon
Mhm.
Musk has said, the hardest part about building the Tesla wasn't building the electric car, and figuring out what needs to go into it. It was just figuring out how to get the manufacturing right, right? And so that's a challenge for any of these newcomers, and some of these bespoke, like there's some really cool looking autonomous shuttles, but are they gonna, there are electric car companies that aren't getting the manufacturing right. Just regular old, you know, companies that they're, just with regular sort of looking vehicles, not these bespoke or these purpose built shuttles. So how do you have any sort of opinions on how these um, companies are going to fare, who are trying to build these new electric vehicle platforms? Are they going to are they going to just continue to have challenges, or are they going to sort of come out of some funk at some point?
Um, wow, that's a lot of questions. I mean, building a new platform is a large capital expense, period. It takes years. There's a lot of know-how that isn't patented. Um, and anybody who's going to try to do that is going to have to go through that. Just think about the idea that you have to make something that's robust against vibration, temperature excursion, shock over 12-year lifetimes, warranty and liability. That's hard. Right?
Yeah.
Like anybody who doesn't understand that should just stay away from the automotive industry. Just like
So,
you're
and
just,
that's just to build. That's to build, a subset of vehicles, but then to scale that to, 10,000, 100,000. I mean, the manufacturing
hmm
is apparently a huge challenge, and getting that right, um, is difficult. So yeah, I don't know. I mean, that's one of the reasons why we've sort of more recently veered away from those types of vehicle platforms, just from an integration standpoint, because there's that they're cool and they're interesting, but there's that road ahead that needs to be kind of forged, I think. I just was
well,
curious if you've had some experience with them, with your, selling your technology into that space.
I think that anybody that's trying to sell to the OEMs right now is going to be extremely frustrated with the OEMs. The OEMs are just very slow. Um, they're 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 used to controlling their audience. They're used to telling their audience when something is going to be ready and them waiting for it. With global competition, especially with China, that's and like before, like technology advances and the new cars were kind of lockstep. Now I think it's I think it's ridiculous. I think it's like that. Like this is technology and this is it's so bad. And this is what McKinsey calls the productivity gap with
Hmm.
OEM. It's just it's not good. Um, so I I actually think the cell phone industry is going to mirror what's going to happen with automobiles, and this is my opinion. Take it for what you will. I think you're going to see a separation between people who make the vehicle and the people who sell the vehicles. In the way that you see Android and you know cell phones. I think there'll be some major players, and I think whoever realizes that first will actually probably be around in 15 years. Um, and I think there's going to be one or two to apples, right? Like people who just vertically integrate, like a Tesla.
Hmm.
But I think it's amazing what the parallels are like, right? It's amazing what the parallels. I think you have to break up if you want to make a lower cost system. that can compete with the technological advances, I think you're going to see the vehicle platform manufacturers separate away from the phone branding, right? Um, or at least the software separate from the hardware in in the same way as your XYZ cell phone provider separates away from Android or
Yeah.
Google. But not exactly the same way, because there's a large maintenance component, liability component. So, but what I think will happen was I think you'll see a lot of people create these platforms, and then people white label them, sell them as their own, kind of retrofit, put different things inside the cockpit thing. I think that's where that's going.
Hmm.
I think if you ask me, I think that that's where the automobile industry will be in 15, 20 years easily. Because the way it's being done right now is, unfortunately for the OEMs, they've lost pace with technological advancements. The technology that should be in vehicles versus the technology that's in vehicles is so backwards.
Hmm.
Just go to China and take a look at their cars. Yeah, sure. Their cars only last 3 years. Okay, fine, whatever. They're only built to last 3 years, by the way, because they're cheaper in some cases. So it's like that's okay. The United States builds great vehicles. So does Europe. Last a long time. And as long as you can, sustain that model, maybe with over-the-air updates and different things, that can work. That's not where it is, and you're just going to see that sort of get bigger and bigger. And then what's going to happen is newer companies will come in, fill that gap. The OEMs can try to buy them and sort of continue that, where they just acquire new technology, sort of eat it up. But here's the other thing that people don't realize. Tesla is worth market cap wise more than all car companies combined in the United States.
Yeah.
Like that's backwards. That's so backwards, right? You're so it's almost like there's this brand baggage that's built into the legacy OEMs, and there's nothing they can do about it. I don't know what you would do about it. And that brand baggage, that ability to have a market cap that's suppressed so much, um, is hampering you, right? If you took Tesla away, Toyota would be the most expensive vehicle brand in the world, at like 250 billion, right?
Mm.
Market cap wise. Toyota. Um, Everybody else, and then look at the number of car sales and the revenue they bring in. It's a completely different number too, right? Like Tesla doesn't bring in a lot of revenue. Their margins are typical. The market cap's way up there, right?
Yeah.
Ford and GM and Stellantis, whose revenue is huge, but their market cap is below revenue. How does that even work, right? And there's only a few industries that are like that. They're like typically like wholesale things, TVS, your Whole Food, stuff like that, where the revenue far exceeds the market cap of the industry. So they've got a disadvantage in the beginning. Any new entrant that comes in has the potential to have a much higher market cap, and I think that in itself should tell you that that industry is ready for change.
Yeah. No, that's a a very interesting analysis there, and perspective on that. And I mean, is this just kind of going back to um, what you're doing next? Can you speak to that a little bit more, or like, or
Um,
is this something you want to hold off on, or
Yeah, I mean, I think we're really interested in we assembled a team that just understands perception, sensors, AI, Gen AI, the new sort of new Gen AI, and you know, augmented reality kinds of things really well. We know the vehicle industry. We have a lot of partners, and so we're excited about giving consumers like this experience that I think they really want and they're not getting. And like I said, I think we also try to work with with the OEMs, but I think it's difficult to work with the OEMs right now just because they're not. Yeah, the OEMs are incentivized not to fail. They're incentivized not to make mistakes. their entire and, you know, of course, they're incentivized to, like, make new sales, but unfortunately, this other overwhelming thing of cutting costs, uh, uh, dealing with chip shortage, the, United Auto Workers, the EV transition, all these things basically makes them less innovative. Um, it's really not their fault. It's a systematic issue with the OEMs. They're not designed to be really innovative, unfortunately. And while that may work when you control your consumer base, it certainly does not work when you start losing control of your consumer base to global entrants in that race. And I think that unfortunately is what they're going through right now, opening themselves up for huge competition from areas where they don't see it.
So that kind of speaks to like the aftermarket, right? Space as another path to, revenue in that world, I guess. Um, what did you ever? What was the company that the guy he had like the phone and it did the analysis of things? What was his? Do you know who I'm talking about?
Coma?
I'm sorry.
What, when you hook up your cell
I'm sorry.
phone?
He had a phone that sort of he had some sort of like ADAS system on the cell phone.
Well, the only company that I can think of is Coma.ai.
Yeah,
Yeah,
that's it. That's it.
okay.
Yeah. Yeah. I thought it
Right.
was comma. Yeah, comma dot AI.
Trauma coma, I don't actually know.
Um, but yeah, I don't know actually what really ever came of that. I haven't
They're still
followed
there,
that.
and you still
Are they
do it.
still there? Yeah.
It's a pretty it's an it I'm not gonna talk about the company or its founders, I don't really know them that well. But the system is kinda cute, you know, plug in your phone to, like, the I guess would be the CAN bus of the vehicle,
Yeah.
and it you just put the camera of the phone through the windshield, looks out, and then it can start controlling the vehicle. Yeah, it's not yeah, I don't think you're gonna get any warranty and liability to continue to work for you with
Right.
it, but it's a cute system.
Yeah. Yeah. Well, I guess just a couple more questions because I know we're coming up on, you know, a time limit here for yourself, but I guess Steve Jobs described the arc of companies. This is kind of the innovation entrepreneurship kind of questions and get your thoughts. He's like, when these companies go from innovator led CEOs to like marketing CEOs to financial CEOs, um, and rightfully or wrongfully, he's saying, that's sort of the mark of trouble ahead for these companies. Um, what's your thought on like high tech companies and sort of you're I guess you're obviously an innovator. You come from that background. When you see high tech companies being led by, yeah, of course, Elon's the ultimate example these days in terms of the embodiment of this, but the innovator CEO versus these other types of folks who come in and in these high tech spaces. Do you agree with that sentiment, or do you kind of think that it's overly generalized?
Yeah, I agree 100%. I think you're living in a world where technology advancement is too fast not to have somebody who's technologically savvy at the helm, and I think you see over and over again that that is ends up, putting the company, uh, in a worse situation than it was. Yeah, unfortunately, I agree with that.
Yeah, I mean, I guess the flip side of some of the VCs are, well, some of these innovator CEOs, they don't know how to grow the business or whatever. But on the flip side, um, what is the business? It's it should be the product, right? And if you don't have a good, solid product, and it's you don't put a lot of attention into into making sure that that's something that's going to be of interest to the people who are buying it, whoever your end customer is, then yeah, you're not you're gonna there's no amount of marketing there's no amount of like cost cutting and a financial manipulation that you're going to be. I mean, you still need to have marketing, you still need to be cost conscious, but but like to me, those are easier, relatively easier problems to solve than um, coming up with it's not just an innovative product, but a product that people are going to want to buy, right? And consume and use. And you need that innovator CEO to lead the charge, I think, through its growth phase.
What's the definition of the CEO? To provide the vision for the company? What's the definition for the president? Execute the vision
Hmm.
of the company, which is really essentially the CEO. I think the CEO role is sort of, in some cases, potentially changing to the people who talk to the bankers and the investors. And because the investors and the bankers sort of demand that they talk to a single point of contact, which is that company's leader. So I think there's an inherent mismatch there. And I think companies and teams, especially because there's no CEO that runs the company completely, right? Every CEO has a team they trust. It's a C-suite. You work together, and you kind of do things with it. I think for companies that want to have huge market caps, be successful, I firmly believe that they need to put the visionary at the top and then have a team around them that helps them execute the vision. I think if you follow that model, you will have a very successful company. So this idea that, okay, your CEO was the engineer, and but he can't scale it. Look, don't. That's the dumbest thing to do, is to take away that vision. Um, for investors that are out there, or people who are, looking at scaling, then change the team around the the visionary, to complement him. Add people where his weaknesses are, um, and try to make that, I think, work. Because if you lose the vision, you see it over and over again. The company just starts sort of dying, right? They
Hmm.
lose their way. It's so obvious. It happens so much. Now don't get me wrong. There are places where that doesn't matter. Like if you're going to make a new toilet paper company, yeah, marketing is probably the most important thing, right? Because that's. But you're talking about technology companies.
Yeah, high
Technology
tech. Yeah.
requires that you take this complicated thing that is technology, which is always evolving, and and then you distill it into a way in which you can create a company that is profitable. That is very difficult to do if you don't understand technology. It's kind of a simple, obvious thing, but very important. And teams that are designed and built around the innovating and staying ahead technology, and then quickly figuring out how to productize, make that into a product, and monetize that, are winning teams, in my opinion. Those are the teams that are going to be around for the longest amount. Just think of lots of examples, I think, where you saw that happen,
Mhm.
in the correct way. Um, you know, I think I think Apple for a long time was, around the innovation. I think from Apple was that he was super passionate about how the technology should look like, right? And then his strengths, which is understanding what consumers wanted and how they wanted to be, and then he pushed the technical people and the business people to sort of build that company around that. And it was really good. I don't think he was either a business person or a technical engineer. He was just a visionary, right? So it doesn't mean you have to be a visionary technically, right? But you do have to understand the things that you need to know about that particular industry. And in the case of Apple, it was the user interface,
Mhm.
right? I think the human machine interface for Apple was, to me, their innovation. He just had an amazing way of figuring out what people really wanted to do with their iPod and then their cell phone and how it should look, and the iPad, and how, that to me was an amazing innovation. And they actually have people that have sort of carried the torch on that decently well, right? In Google, you still have the founders fully at the top, I would say they made the CEO somebody else. But I think if you had made them the CEO and then made the president somebody that could just execute the vision and kind of switch that would have worked too.
Yeah.
Um, but I still think you need to keep the visionaries at the very top making the calls. And I mean, think about when Google, I think it was Page bought Android, right? Without,
Mhm.
I think this famous story is without, he didn't even tell Schmidt, whoever at the time it was, I believe it was him. And there was a little bit of a disagreement, but it's like one of the biggest calls ever, right?
Yeah.
To get Android. So look, my opinion, at or near the top, you've got to have the visionaries and you got to build a team around that. That's it.
Yeah. I agree. Now, but of course, I'm going to be thinking about how to make a high tech company out of toilet paper. But so
Yeah,
thank you for.
it's
There
coming.
must be a path there. But no, interesting. And I think so. What would be kind of your advice to engineers and young entrepreneurs who are kind of looking to start a high tech company? Um, like what's their path? What's the path to get there?
Um, I think the worst thing you can do is if you're the visionary entrepreneur technically, you get bogged. You have to hire a team around you that I think can handle some of the marketing, investor relations, public relations, um, execution of the business. Don't try to do that just on your own. I think at the beginning you have to do that a little bit, but you know, don't lose I mean, people at the very beginning, your innovative spirit, your vision is really important. Um, it will get diluted the moment you play telephone tag down your management chain. So, or telephone down your management chain. So you have to stay engaged with that, but that doesn't mean you lose control of the company. And I think a lot of entrepreneurs worry about that. And I think VCs too, to be honest with you, they force people to be something they're not. This is what led to, you know, sort of hiring a CEO that kind of replaced Page and Flynn, right? Right.
Hmm.
And
Brand, yeah.
Bryn, sorry, yeah, I knew it was wrong. Um, you know, it, it I think in retrospect, making them the co-CEOs, potentially having a president that could execute would have been as equally fine. But I think understanding that you don't have to be that person right away, and it's very important for you to stay focused in in the technology aspect, but still kind of like take a 50,000 foot devil, delegate to your team. It is really your team that's running the company, not necessarily you all the time. You're there to make final decisions, but if you get into a good cadence, you should be able to do that. And the startup at the beginning, you're doing so much fundraising, so much hiring, and so much technical innovation. Um, that you really do need a good team. And I think a lot of entrepreneurs, when they start in, they think that they have to do everything, right? And that's not true. I think that's where they made a mistake. One thing that I think did well was I did get a team around me that helped me to do a lot of things that I wasn't good at. Jordan Green, who was really the business side of the company when I started AI, Ransom, who really helped me a lot with the financial aspects of it at the very, very beginning. Barry Bankin, who was my right hand man when I did any of the engineering and technology things. So I hired a team that was going to make my weaknesses not seem as weak. And then over time, obviously, I learned a lot from them, and I kind of rounded out into a much, I think, a good CEO with a good technical background, able to do leadership, understand the corporate environment, understand financial aspects of it. And you pick that up. You don't have
Yeah.
to pick it up right away though. So I think my
Yeah.
advice is to understand your weaknesses and combine yourself with people who can hide, not hide, but help you with those.
Well, that's excellent. That's excellent advice. And well, just one more question. It's kind of
I
it's
got time
still
for a little bit more if you want to stay a little bit more. It's up to you.
yeah. Well, I I'm thinking, it's always good to kind of sometimes I'll ask I'm not as grim, but I'll say, what do I want on my tombstone kind of question. But this is more like what if we have if we meet again 10, it's 10 years from now. And obviously, hopefully I'll have some hair. It'll probably be a little more gray, but, and we have a conversation and I say, Lewis, highlight, you know, what just transpired since our last conversation? Hopefully we'll talk before then, but what
Yeah.
transpired since our last conversation and what's going on in the world right now? And the year is 2034. What's going to be going on? That's going to be like, wow, Paul, you wouldn't believe what's going on right now in the high tech world.
Um, I think that the mechanism, let me talk about AI first. I think that the mechanism that created the natural language processing Gen AI artificial intelligence branch, which is taking over the world right now, will expand into more than just natural language. It'll expand into images, video, sound, complex interpretation of scenery. I think people will start figuring out how to use that same mechanism, like the transformer memory storage, stuff like that, coupled with deep learning and training. I think that's going to take a leap forward, and potentially that's what is going, and that'll change the perception engines on any robot, including vehicles, to be much more human-like. Um, and I think you'll start seeing tags on AI, on stuff with AI, like the AI computer, which just means it can do AI algorithms better because it has certain hardware and that is designed to do that. I think the AI car will be a thing. Um, so I think you're going to start seeing uh, the what looks like a Gen AI for natural or language expand. And I think that if everything goes right and we don't do something stupid as a civilization, um, what you'll see the regular person who does today's job be able to do that job 10 times faster. Uh, and conversely, I think startups will be able to do what they used to do with 10 people with one person. And you might say, oh my God, well, what does that mean? Does that mean that, jobs are going to go away? No, I just think it's going to raise the level of productivity a lot, right? I think people should not be worried about AI taking their jobs. I think they should be thinking, oh my God, I'm going to be able to get so much more done in the same amount of time that I used to get one thing done, right? And so I think that will happen. Could be wrong, but that's where I think it's going. And I think the second thing I would say is that I don't think the OEMs will be the same. I think just because they sort of reached the point of no return, and you might say, well, Louis, let's say these new entrants come out. Don't you think they're just going to buy them? I don't. And the reason I don't think that's the case is because I think it's the same reason why GM makes more cars than Tesla, but can never dream of buying Tesla because their market caps are so backwards, right? It is, they are not, I don't know if they've reached the point of no return, but I think they're blockbuster. And I think Netflix is already here
Yeah.
and they're like, oh, it's too late. I think that's happening. And I think like I told you, the Nokia Motorola analogy with the smartphone, I think the cars are going that way. So I think it might be too late. The point of no return may have already happened with some of the OEMs. Some of the OEMs may realize that and pivot a little bit to be more of the general platform, but sort of give up the customer.
Mhm.
I don't know exactly what will happen with that, but I do know that they will not be the same companies they are in. I firmly believe that's not the case. I don't think they can acquire their way out of this one.
Interesting. Interesting. Well, that's a lot to think about there. So, well, thank you so much, Louis. This has been a fantastic conversation. It's just grateful to you spent the time here and that we could catch up and just some really great things to think about here today. So I really appreciate your time and appreciate what you do and your pioneering endeavors in this space have been amazing. So thank you for sharing some of that with us.
Well, I appreciate you. Thank you for having me. And I can say the same things about you. But I look forward to doing this again. I enjoyed it, and I thought it was a great conversation.
Well, I'll take you up on that. That'll be wonderful. And before 10 years for sure.
Yes, I think it might be too long.
All right. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.